Okay. So what is experimentally observed for mass number lie in between 150 to 200, also even of course that case is even, and also for mass number greater than 230, again even case. Experimentally it was observed that there are many states like this, and with increasing that energy, separation between two successive level is increasing. So it was observed that, so this they have experimentally shown for tungsten. Of course, mass number is 174. Okay, and ground state is corresponds to spin is 0 and parity is even. For first excited state, this is spin is 2 and parity of course even. For then for second excited state, that state is 4 plus, then third is 6 plus, and fourth is 8 plus, and so on. So this separation between ground and first excited state for this W174, it is around 100 kilo electron volt. 100.
So what is 0 plus 2 plus, sir?
Yes. So ground state 0 plus means spin is
Parity,
0,
no?
parity is plus, positive even. First excited state spin is 2, parity is even, and so on. So for all even nuclei within this, they are getting this kind of spectra. So this is from experimental result. And interesting fact is that separation between two successive level is getting increased with increasing that energy with increasing that energy value. And also they have noticed that for this mass number, when they have performed that quadruple experiment, what they have observed for this mass, for mass number 150 to 200, they have observed large quadruple moment, large negative quadruple moment, negative quadruple moment. And for mass number greater than 230, they notice large positive quadruple moment. So what does it mean? What does it mean?
Sir, ऊपर वाला का B greater than है, नीचे वाला का A greater than.
Exactly. So the meaning is that they are not spherical. They are not spherical. So their structure is deformed. Okay.
So these are experimental results, right?
Yeah, experimental result, but you can conclude, right? If you have quadruple moment is large, so ideally for sphere it will be 0, right? Huh?
Yes,
No.
sir.
Yes,
And
sir.
so if you have large value, it means they are deviated from that spherical structure. So they are not spherical, so they have deformed structure. So if you put this this deformed structure in rotation, if you rotate this this kind of nuclei, then its configuration will change. For example,
सर रोटेशनल मॉडल में क्या करते हैं?
रोटेशनल मॉडल में क्या करते हैं, रोटेशनल एनर्जी निकालते हैं, जो आपको मिल रहा है ना, सो इसका एनर्जी कितना होगा, है ना, you can calculate. So if you know that ground state energy of first level, you can calculate for other. So also if you know the energy of two level, and if you know spin or of one state, you can calculate that spin of other state also. Okay. So what is actually happening? Suppose you have disk, perfect disk. Suppose you have perfect disk. Okay. Now suppose if you are rotating, it's about this axis. So there will be no change in configuration, right? So if you rotate it, there will be no change in configuration, right? It will remain be like this. No.
Yes.
So suppose you have disk, okay, and that axis you have chosen, that is central, about the center. So now if you rotate it, there will be no change in configuration. Okay. But suppose you have deformed structure. So you have deviated this structure. I'm taking like this. Now if you rotate, its configuration will get changed. Okay.
So here configuration means shape and size.
Yeah. So if you configuration means now if you rotate it, so it will
Yes,
not
sir.
initially how it is looking like. After rotation, its configuration will be changed. It will be looking different, right?
Oh, means after rotation how it is
Yes, yes,
looking.
yes. So according
Okay,
to
sir.
quantum mechanics, for different kind of configuration, will have different energy. Okay. So
सर
yes.
आपने जो सेकंड वन ड्रॉ किया है ना वो मतलब सेम लेंथ पे है सेंटर से मतलब
Exactly.
रेडियस
Now
सेम
suppose
नहीं है
हाँ सपोज आपने मूव कर दिया कुछ, है ना, नाउ आपको सपोज मान लो इस तरह क्या आ गया, तो इसका कॉन्फ़िगरेशन चेंज नहीं दिख रहा आपको, है ना, ये कॉन्फ़िगरेशन डिफरेंट है ना, नहीं, कुछ सम अमाउंट आपने मूव कर दिया, नहीं, so this energy will be
सही
different from this. Yes. Yes. So according to quantum mechanics, if you are changing the configuration, so different configuration will have different energy, and you know that energy, and that energy basically rotational energy. So you know that rotational energy, how it used to write, L square by 2I, right?
Yes.
So if you have deformed structure, if you keep put in rotation, it will its configuration will get changed, and according to quantum mechanics, different configuration will have different energy, and if you are rotating, so of course that energy will be rotational energy, and you know that rotational energy from this classical mechanics, L square by 2I, and by using quantum mechanics, how much will be that L square? L square of psi will be how much?
J into J plus 1.
So I'm using L here, so of course I'll use L. So L into L plus 1 H cross square. Okay. So if you substitute it here, then how much will be that rotational energy? It will be simply L into L plus 1 H cross square by 2I.
2m.
Okay. So this will be the rotational energy, and what is the meaning of this? What we can say from this equation? The energy is discrete in nature, right?
Yes, sir.
Is it clear to all? थोड़ा इसको सीख लो क्योंकि यहाँ से क्वेश्चन आते हैं नेटली, ठीक है. So you got that rotational energy. Okay. Now can you tell me how is the allowed value of L? I expect at least one answer.
So 0 to n minus.
No, you tell me what will be the allowed from first. थोड़ा सोच के बताओ. Any on?
So plus minus 2.
First, how much? So first, I'll take L equals to how much? 0.
Even values.
Exactly, because what you have observed, there is 0 plus 2 plus 4 plus. So L equals to 0, energy will be how much?
H square by 2I.
0, right?
Yes, sir.
And
Yes,
that corresponds to 0 plus. Okay. If you take L equals to
Ground
on,
state.
this is for ground state. Very good. This is for ground state. Okay. Now if you take L equals to on, how much will be the energy? How much will be the energy?
2.
H
Square
cross
by 2i.
2h
Y.
cross square by 2i,
Y.
right? Okay.
Yes, sir.
So this corresponds to on minus, right? No, but
Yes, sir.
this doesn't exist. No, according to experimental results, so this doesn't exist. Then you have to consider. Yes.
हम ना पिछले लेक्चर्स को जब पैरिटी लिख रहे थे तब हम जे फैक्टर रेस टू पैरिटी ऐसा करते थे ना,
हाँ.
लेकिन अब हम एल यूज कर रहे हैं, मतलब
यहाँ पे स्पिन को इग्नोर कर रहे हैं, है ना? इट्स गुड क्वेश्चन, बट यहाँ पे स्पिन को इग्नोर कर रहे हैं. एनीवे, इफ यू आर नॉट राइटिंग लाइक दिस, you can say like for this state it is parity is odd, right? Can you say like this?
yes.
Is for L equals to on, parity is odd. So this state doesn't exist. Can we say like this? Because whatever we have observed from experimental
Yes,
result,
sir.
so this state will never be exist. This state will never be exist. Is it clear to all? Because this state will give you odd parity. So I'll not write this state. Okay. So first ground state, that energy will be 0, and that ground state we know that is corresponds to 0 plus. Okay. Then for L equals to on, it will give you odd parity, so this state will not be exist. Then for yes.
How will say it is odd parity?
Yes, very simple. Minus 1 to the power L,
Minus
and
one
here L is
to
1, so obviously parity will be odd.
Okay.
Okay, so this
Yeah,
state
yeah.
is not. So minimum energy that is 0, and that minimum energy corresponds to 0 plus. Then you have to choose L equals to 2, right? So this will give you how much?
4h cut square.
6 h cat square by 2. So since this is a energy, that will be first excited state, and that state we know that is 2 plus. Then again L3 will not be allowed. Okay, this will not be allowed. I am not writing here. You can write energy also. Then L equals to 4. That will give you how much energy?
So 20 H cross square by 2.
20 h cross square by 2i, right? Then L equals to 5, again not allowed. L equals to 6, how much it will give?
42.
Exactly. So 42 h cross square by 2i. Okay. So
Sir,
yes.
so the states which are not allowed, these are
Ah.
means experimental results that they are not allowed.
So see, first they have observed experimental result, then they
Yes, sir.
came to the theory. So for grounds, that allowed value of L is 0 to n. Southern already told that answer. But all value will not be allowed, because when L equals to 1, so of course L equals to 0 will give you ground state, and that state we know, right? Then L equals to 1, that is giving odd parity. That's why this state will not be allowed. Okay. Then we are taking L equals to 2, and that is giving even
First
parity.
excited state.
So that will be first excited state. This will be
Okay,
your
sir.
okay. Now can you calculate that energy separation between first excited state and ground state? So it will be how much? E
Wait.
L equals to 2 minus E L equals to 0. That will be simply 6 h cat square divided by 2i. Right. Now if you see, if you increase that L value, now if you calculate for second separation. So first I have calculated separation between first excited and ground state. If you calculate that separation between second excited state and first excited state, so L equals to 4, energy L equals to 2. So it will be how much?
So 14 H cross square by
14
2.
square by
Very good. 14 h cat square by 2i. So what you can say from here? What you can say from here?
energy gap is increased.
Exactly. Energy gap is getting increased. Okay. Now what will be the ratio of this ratio? E4 plus and E2 plus will be how much? How much? 20 by 20 by 6, right? So 10 by 3, that will be 3.3. You can write. Now I will write one question. Please do one question.
सर E4 प्लस बाई नीचे वो क्या लिखा
2
E2
plus
plus.
का. It's 2 plus. Now write one question.
सर
Yes.
मतलब हमारा जो मॉडल है उसमें हम ऑड वैल्यू नहीं ले रहे, इसके वजह से ये है कि मतलब
ऑड पैरिटी एक्सपेरिमेंटली मिला ही नहीं ना, तो फिर हम उसको कैसे चूज करें?
ओके
जो आपको एक्चुअली पहले एक्सपेरिमेंटली देखा गया है, फिर आपका एक्सपेरिमेंटली क्या देखा गया इवन जो आपका स्ट्रक्चर है फॉर लार्ज मास नंबर, दे आर डिफॉर्म स्ट्रक्चर, so if you rotate their configuration will be changed. So according to quantum mechanics, if you have configuration is changing, you will have some rotational energy. Then they have taken the help of quantum mechanics, that rotational energy can be written that like that, L square by 2I. Then they have chosen for different L value. L can run from 0 to n. So they have chosen in least value is 0. So that corresponds to they are getting even parity. So they have taken this is your ground state. Then they started increasing, but L equals to 1, that will give you odd parity, and experimentally it is not valid. So they have ignored that. Then they have taken increase that L value, and they have calculated different energy level. Now is it clear to you? Now
सर ये रेंज के लिए ना सर,
हाँ
वैसे लो सर, ये जो रेंज दे रखी है आपने 150 200 ग्रेटर देन 230, अगर इसे लेस देन होगा तो सर करेगा
नहीं, लेस देन में नहीं, एक्चुअली आपका ये लेस देन 150 के लिए जो आपका इवन न्यूक्लियर है उसको ऑलमोस्ट स्फेरिकल माना जाता है, ऑलमोस्ट स्फेरिकल होता है।
यस सर, वही पूछा था सर।
स्फेरिकल के लिए नहीं है वैलिड।
ओके सर।
Now please write one problem, okay? Because I have to proceed, I have to do different problem. Okay, please write that problem. First excited state of rotational spectrum of uranium. What is the atomic number? What is the atomic number of uranium?
92.
235
92.
Atomic mass है 235 and 238.
Okay. So first excited state of rotational spectrum of uranium, nucleus is 45 keV.
Nucleus
is 45 keV, kilo electron volt. Calculate the energy of the second excited state.
सर एनर्जी कितना है
45 keV.
सर 450 किलो इलेक्ट्रॉन वोल्ट।
How much?
एक मिनट सर, एक मिनट, नहीं गलत, हाँ सर 4 नहीं गलत हो गया सर।
गलत नहीं होना चाहिए। देखो आपने कितना बड़ा गलती कर रहे हो।
सर 150 किलो इलेक्ट्रॉन वोल्ट सर।
हाँ, उसीलिए मैंने पहले आपको लिख के दिया था। अभी आपका देखो रेशियो सेकेंड एक्साइटेड मतलब क्या है 4+, राइट। फर्स्ट एक्साइटेड मतलब 2+, रेशियो कितना था अभी लिख के दिया था 3.3, राइट। ये गिवन है ना, आपको कैलकुलेट करना है ये, राइट। सो ये जो हो जाएगा आपका E4+ मतलब सेकेंड एक्साइटेड स्टेट, सिंपली कितना हो जाएगा 45 × 3.3 किलो इलेक्ट्रॉन वोल्ट। So it will be 150 kiloelectron volt. Okay. So it's, is it clear? Okay. I think it is clear to all, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now we'll go to deuteron problem. So what is deuteron actually?
Sir,
तो
one
लाइट
eight,
निकले सर
H12.
What does it mean?
Sir, ये 148.5 आ रहा है sir.
one proton and one neutron, sir. Yes, sir.
कितना आ रहा है?
148.5.
देखो, E4 plus divided by E2 plus, right?
So 45 into 3.3 करेंगे ना?
हाँ, 10/3 करो. मैं तो एग्जैक्ट नहीं लिया, आप ले सकते हो. यही तो था ना 10.3, 10/3.
Yes, sir.
ये कितना हो जाएगा?
450 by 3. Oh, तब 150 आ जाएगा sir.
हाँ, मैं अप्रोक्सीमेट लिखा था.
Oh, okay sir. मैं 3.3 लेके किया.
सर 149.85 आ रहा है जी 150.
ठीक है. अब ड्यूट्रॉन क्या है? सो विल स्टार्ट ड्यूट्रॉन प्रॉब्लम.
Hydrogen with
तो लिखो, it is the only bound system of two nucleons. You know deuteron, right? Deuteron means on H2. So if you write structure, we will have a nucleus, one proton will be there, one neutron will be there, and of course one electron will be revolving. So it is the bound state of, it is the only bound state of two nucleons. What does it mean? What does it mean?
और
One
सर इट इज
proton,
Proton, neutron, it is exist, but two nucleons like proton, proton, that is not existing. Okay. Also neutron, neutron, that is not exist. Okay. Now binding energy according to experimental result, the binding energy. So we'll start writing the property first, then we'll solve the Schrodinger equation. Okay. So properties. So experimentally what was observed? The binding energy. Binding energy कितना है इसका? बाइंडिंग एनर्जी कितना है? किसी को कोई आइडिया? कितना है? 2.25 मेगा इलेक्ट्रॉन वोल्ट. इसका मतलब बाइंडिंग एनर्जी पर न्यूक्लियन कितना है? ऑलमोस्ट यू कैन से 1.1 मेगा इलेक्ट्रॉन वोल्ट. व्हाट डज इट मीन? What does it mean?
It is highly stable.
लो स्टेबल सर लो स्टेबल
Exactly. For highly stable, you need to have that binding energy per
7
nucleon.
होता है ना
हाँ,
सर हाईली ग्लो 7 होता है ना 7 8
हाँ, that's what I'm writing. For
Sorry,
highly
sir.
stable, this much. So you can say this is
सर लो स्टेबल है सर ये तो फिर
exactly. So you can write this is weakly stable. Now, can you calculate that binding energy? So that experimental result I have written, can you calculate it? Answer should be yes, right? So this is the experimental result. So theoretically, how will calculate? Z mh plus a minus z mn minus mass of atomic mass of deuteron, and of course there will be c square, right? So how much it will be? Z is on, mh is how much? mh is how much? Mass of hydrogen 1.00782 q, right? Then you have neutron A minus Z is how much? 1, right? So it will be 1.00866 U. Then you will have hydrogen atom, mass of atomic mass of deuteron, that is 2.0141 U C square. Now if you substitute that U equals to 931.5 MeV per C square. Okay, if you substitute it here, okay, then you will get binding energy. I have calculated it, you can check it. 2.21 MeV. This is very close to experimental result. So first property, binding energy, right? That is very less. So this is weakly bounded. So let me do quickly. Then we'll solve that Schrodinger equation, and we'll make that conclusion.
सर स्क्रीन ब्लर हो रही है,
हाँ,
ज्यादा नहीं है मतलब सर, पर आप बहुत छोटा देख रहे हैं तो वो ब्लर दिख रहा है सर।
अच्छा,
सर ये लाइट की वजह से
लाइट की वजह से हो रहा है। एक मिनट,
आई थिंक फोकस हिल रहा है क्योंकि बीच बीच में थोड़ा ब्लर
ठीक
हो
आ रहा है?
जाता है। नहीं सर, कलर से चेंज दिख रहा है।
सर ठीक है।
अब ठीक है? इज इट ओके?
हाँ ठीक है सर,
ठीक है,
चल जाएगा सर काम।
ओके। ठीक है, अब स्पिन पैरिटी कितना है? तो सेकंड प्रॉब्लम, सेकंड प्रॉपर्टीज क्या है? स्पिन पैरिटी। प्रॉपर्टी नंबर 2, स्पिन पैरिटी। So this is JP. So on P plus, on plus, can you calculate spin parity? Of course, parity will write in upper.
यस सर 1 पर।
Can you calculate? I will calculate.
सर हाफ प्लस होगा ना?
No, 1 plus. So you see, this is
उसका प्रोटॉन एंड न्यूट्रॉन को ऐड करके।
so you have one proton, right? So according to cell model, you can arrange like 1s half on, right? And also you have one neutron, right? So you see there is one proton. So if you make it configuration cell model, so that proton will lie here on s half, and also similarly neutron will lie in on s half. So for this your JP is half, LP is 0, then again half, and of course ln is 0. ये तो हम लोगों ने पढ़ा है, राइट? सेल मॉडल में।
सर इसमें P you are saying कि will lie in 1.5, मतलब प्रोटॉन और न्यूट्रॉन।
हाँ, दोनों देखो, अनपेयर्ड के लिए हम करते हैं ना सेल मॉडल में, इफ यू रिमेंबर सेल मॉडल।
यस
So
यस
both are unpaired. So ground state, if you remember, ground state was 1/2. So it will feel like here, there. So you see now calculate.
इसमें 2 आ सकते हैं ना? ओके सर।
Please revise that your cell model. Okay. So JP plus LP. हाँ,
तो पैरिटी हमारी हाफ प्लस आनी चाहिए ना, जे लिखते हैं हम।
Parity?
तो रिप्रेजेंटेशन मतलब जे रेज टू पी, मतलब यहाँ
no.
JP है।
See, JP is half L. For S, L is how much? 0.
नहीं सर, वो नहीं बोल रही हूँ मैं।
क्या?
हम रिप्रेजेंट करते हैं ना जे प्लस जे माइनस,
हाँ,
उस रिप्रेजेंटेशन में हाफ नहीं आने का है, हाफ रेज टू प्लस हाफ रेज टू माइनस, ऐसा नहीं आएगा 1।
यहाँ पे आप बोल रहे हो ये?
हाँ हाँ हाँ
नहीं, वही हम कैलकुलेट कर रहे हैं, अभी कैलकुलेट करने दो मेरे को, वही मैं कैलकुलेट कर रहा
ओके।
हूँ।
हाँ वो, हाँ फॉर्मूला से करते हैं। ओके ओके, सॉरी
हाँ,
सर।
JM LN कैलकुलेट करो। ये JP कितना है? हाफ है, LP 0, हाफ, अगेन 0. So half plus half, it will be 1, right? So this is odd. So odd के लिए क्या करते हैं हम? J को, रिजल्टेंट J को JP प्लस JN करते हैं ना। तो कितना आ जाएगा ये आपका? हाफ प्लस हाफ, that will be on. And parity, you know, parity always minus 1 to the power LP plus ln. So obviously both are 0, so minus 1 to the power 0. It means plus 1, so it will be even. So you can theoretically clearly say that JP or JP, of course it will be 1 plus. Now binding energy हम लोगों ने calculate किया था कितना 2.25, right? So what you can say from that? You can say like that energy of that system is minus 2.2 mega electron volt. Can you say?
Yes, sir.
So please remember that when you will solve that Schrodinger equation, it will be helpful. So binding energy अगर आपका system का 2.2 है, इसका मतलब system का energy है minus 2.2.
सर टोटल J1 आया था ना, JP प्लस
तो टोटल J1 आया था. अब थर्ड है आपका ground state of that.
सर ब्लर हो गया है.
सर स्क्रीन पूरी लो.
हाँ पूरी ब्लर हो गई.
एक मिनट. अब ठीक आ रहा है?
हाँ सर.
Yes, sir.
ठीक है, चल जाएगा, नहीं तो बताओ.
Yes, sir. ठीक है.
ठीक है,
चल जाएगा चल जाएगा.
अच्छा अच्छा.
सर फिर ब्लर हो गया सर. ऑटो फोकस हो रहा है सर.
सर ऑटो फोकस
प्रॉब्लम क्यों हो रहा है?
अब ठीक है सर.
अब ठीक है.
यस सर.
Okay. Now ground state of deuteron. So what will be the ground state? For ground state, L will be how much? We don't know, right? So
Yes, sir.
that I'll prove when I'll solve Schrodinger equation. So L will be 0, and there will be two nucleons are there, so they can stay like this anti-parallel, right? Because both are spin half. So that will give you how much? That will give you how much? S equals to 0, right?
Yes,
No.
sir.
And if both are parallel, then S will be how much? On. Okay. Now you calculate by taking L equals to 0 and S equals to 0. J will be how much? 0.
0. Yes, sir.
So this state is not valid, because you know J is how much? J is on, right? No, that we are already know, right?
Yes.
So this state is not valid. Ground state.
we
This will
have
not.
find out that na.
We already calculated. So it means this will not be ground state. Now take L equals to 0 and S equals to 1. So obviously J will be how much? 1, right? And of course you can calculate parity also. Parity will be how much? Minus 1 to the power 0. No. So again it is giving even parity. Here it is giving an even parity, but J is not allowing it. Right? Is it clear what I am saying?
Yes, sir.
So what will be that
Sir.
state? Yes, you have question?
ये LP plus minus 1 is power LP plus ln is parity, right?
Yeah, but here I am taking that orbital part. Here I am not considering any individual. Here the total L is 0. I'll prove that when I'll come to that Schrodinger equation. Okay, here not a individual, here total L.
Oh, okay, sir.
So
and J equals to L plus S. Okay.
So is it clear now?
यहाँ पैरेटिक
Yes, sir.
फाइंड आउट करते टाइम भी हम -1 रेज टू L ले रहे हैं ना.
हाँ, तो L लगे L 0 किया ना,
वही
ठीक है ना. So this state is valid. How will write this state actually? So if you
Sir,
हाँ
predict J equal to 0 not in ground state, how will say?
From previous study, you see, ground state spin we already have calculated. That's why previously I calculated that. No, we already have calculated that, right? On, that is your ground state, on plus. So J is on, it is giving 0. So it is not valid, right? It means ground state cannot be this.
Okay, sir.
And of course, if you see from that basic knowledge, you can say when that spin in previous study also I said that when the two spin are parallel, they will be attractive in nature, you know. And also from that atomic physics, you know, higher the multiplicity, lower the term. What does it mean? If you have higher multiplicity, what does it mean? 2s plus 1, right?
Okay.
So for this, if you take s equals to 1, it will give you 3. If you take s equals to 0, it will give you 1. And according to your atomic physics, higher the multiplicity, lower the term, right? That I'll teach you, no problem, but you know these things. What does it means? If you have higher multiplicity, the energy will be less. Okay?
Okay, sir.
Is it clear? Now,
sir.
so can you write this state? So you write term, right? Like 2s plus 1, then you have L, then you have J. So for this, if you write that state, so ground state, what you can write? 3s, J is how much? 1. So you are expecting this, right? No. And S is how, what the kind of shape of S orbit is? It is purely spherical, right? No.
Yes.
So,
Yes,
so in ground state, that shape should be spherical, right? But जब quadrupole measurement किया गया है, तो क्या मिला है? quadrupole measurement के लिए जब किया है तो मिला है आपका 0.228 femtometer square, and also magnetic moment of deuteron. So quadrupole moment of deuteron, I am writing this notation. And also when they are measuring that your magnetic moment, they observed that value 857 mu n. So mu d नॉन जीरो का मतलब क्या है? नॉन जीरो का मतलब क्या है? This is not spherical.
Not spherical.
Not a
So,
spherical.
but you are getting spherical. So there must be some other mixture of other state also. You know, so this state valid, but in addition to this, there may be some other state. So can you calculate other state? So ground state actually a mixture of this state and other state. That state you have to calculate, and that state should be non-spherical. Now can you calculate that?
सर ये 2s plus 1 LA क्या है सर? ये नीचे
Yeah.
में नीचे.
Yeah.
No sir, नीचे last sentence.
This is your state. In atomic physics, I'll teach you how we'll write that term. So state can be written as 2s plus 1 L J. 2s plus 1 for this state, how much it will be? 2 into 1 plus 1. L is how much? 1, right? L is how much? 0, right? So L is 0, that state is S,
Yes.
and J you have calculated. I'll teach you in atomic physics also.
So this shows that it is spherical.
S state is S orbital is spherical in
nature.
nature. That you know.
Okay, sir.
Now this state you are getting, but magnetic moment quadrupole moment is clearly saying that state is not spherical. So there should be this state, that state should be a mixture of this and other non-spherical cell or orbital. Now can you calculate? So possibility क्या क्या हो सकते हैं आपके पास? L क्या है? 0 है ना? S क्या हो सकता है? 1 हो सकता है. तो इसमें J कितना है? J कितना है? ऑन है. ओके, L इक्वल्स टू ऑन लो, S इक्वल्स टू ऑन लो. J क्या क्या हो सकता है?
sir. 0, 1, 2.
Exactly, 2 on 0 you can write. L इक्वल्स टू 2 लो, S इक्वल्स टू ऑन लो. J क्या है?
3, 2,
3
1,
to
0.
on. On, right?
3 to
No, right?
Yes,
Then
sir.
you take L equals to 0 and S equals to 0. Okay, or you can take L equals.
एग्जिस्ट नहीं करता ना.
हाँ,
सही तो exist करेगा नहीं ना.
L equals to on and
L
yes, that is not valid. You are correct. How much it will be? On.
1
तो जे यहाँ पे भी ऑन मिल रहा है आपको, यहाँ पे भी ऑन मिल रहा है ना, यहाँ पे भी ऑन मिल रहा है, यहाँ पे भी ऑन मिल रहा है, बट कौन सा करेक्ट होगा बताओ, क्या ये करेक्ट होगा, ए स्टेट मिल सकता है, नो राइट, बिकॉज पैरिटी यहाँ पे क्या हो जाएगा, ऑड हो जाएगा, नहीं पैरिटी तो आपको इवन मिला है ना, so this state not is not possible, although the allowed value of L is on, sorry J is on is there, but you have already calculated that parity of your state is even, right, so this is not possible.
Yes,
Okay,
sir.
so this is possible, this is not possible, and of course you see this is possible,
Possible. Yes, sir.
again this is not possible, so this state will be corresponds to what, can you write that term?
Sir, J will vary from my L minus
Yes,
S
I'm
to L
writing.
plus S right now.
J can be, I'll teach you, I'm
This
extremely
point.
sorry that I am using your atomic physics term. So J
Yes,
can be
sir.
right mod of, J can vary mod of L plus S to mod of L minus S. Okay. So what will be that state? Sotan, can you tell me?
सर
3D1.
एक बार बताओगे?
3D on, right?
हेलो सर,
Yes.
प्लीज एक बार बताओगे, मेरा बीच में इंटरनेट चला गया था।
हाँ
ये इसमें से कौन से स्टेट, मतलब आपने क्रॉस और वो किया है, वो
exactly,
क्या
sure, I'll tell you. You see, I'm taking many possibilities, L equals to 0, S equals to on, L equals to on, S equals to on, L equals to 2, S equals to on, L equals to on, S equals to 0. Okay, and I'm
Okay,
calculating
sir.
that J value. Okay, and J
Yes.
we know already calculated, that is on. You are getting J
Yes.
equals to 1 for all possibilities,
Yes.
right?
Yes.
But you see, parity we have noticed that is even parity. So when you are taking
Yes.
L equals to 0, it is giving even parity. Also J is satisfying that whatever we have observed. When you are taking L equals to 1, that is giving odd
Not
parity.
satisfied.
So this
Yes.
will not be allowed. This is giving even
Yes.
parity, and J equals to 1. This is allowed. So
Yes.
and this is not allowed. Now your
Okay.
ground state is mixture of what? 3s on and
3D1.
3d on. Good, right?
yes
Now so total wave function for deuteron can be written as how much? As psi s. This is for s orbital, and ad psi d, right? And of course as square plus ad square, when they have calculated it, and so you know this should be how much? 1.
Sir,
Hmm.
so how can you say that these two states are mixture of ground state only?
That is telling from that your quadrupole moment calculation, because D is non-spherical in shape, you know, and you that quadrupole moment is clearly saying your state is your state is non-spherical. So you already have spherical, okay, that is allowed, but you should have another structure that is non-spherical. Then you will get your that will satisfy your quadrupole moment, whatever they have observed.
Oh, it means you want to say that these two states are mixture. That's why they
Mixture,
are getting
exactly. That's
non-spherical.
what I am
Okay,
writing. Yes.
Okay, sir.
सर
हाँ.
वो क्लियर हुआ, लेकिन ये अभी जो आपने किया था कैलकुलेशन, इससे ये कैसे लिखा, मतलब 3s1 3d1 इस कैलकुलेशन से लिखा है क्या अलाउड? अभी हमने इवन
अलाउड, हाँ, अब इससे ये तो मैंने पहले ही बताया आपको। देखो कैसे टर्म को लिखा जाता है, 2s प्लस ऑन एल जे, ठीक है। तो पहले आपका क्या
Okay,
था,
sir.
हाँ, अब पहले जो क्या मिला था आपको, एल इक्वल्स टू कितना था, 0 था, एस इक्वल्स टू
0
कितना था, 1 था, राइट।
1
तो उसके लिए कितना हो जाएगा, ये कितना हो जाएगा, ये 3, एल
3
इक्वल्स
हो
टू 0
जाएगा।
क्या लिखते हैं, एस लिखते हैं,
आप एस लिखते हैं
और जे कितना है,
और जी के भी
ऑन।
1
सिमिलरली
लेगा।
कैलकुलेट फॉर दिस,
क्लियर,
ठीक है।
थैंक यू सर।
After calculation, after this calculation, when they have performed that wave function calculation, so this is known as normalization constant, right? So they have calculated that AS, they have noticed 96%, 0.96, and AD is how much? 0.04. Okay, so इसका मतलब क्या है? सॉरी, दिस इज ए स्क्वायर AD स्क्वायर। इसका मतलब क्या है कि आपका इस स्टेट में रहने का जो प्रोबेबिलिटी है कितना है? 96% है, एंड दिस स्टेट में कितना है? ओनली 4%। ओके, so ground state is a mixture of 3s on and 3d on, and probability of this state is 96%, probability of this state is 4%.
So then also with this 4%, it is able to deform the thing.
Yes, because you see quarter pole moment is very less. Okay, because this is
Okay, sir.
not spherical. Now we'll solve Schrodinger equation. Time कितना हुआ? Time हो गया क्या?
7:40, yes sir, 7:40 हो गए सर।
Okay. So you have to stop, right?
Yes sir।
Okay, then we'll stop. We'll do that. Okay. Any question?
No, sir.
Clear.
Okay.
Atomic is going to start from when, sir? You are going to teach atomic.
I'll teach everything. Modern physics I'll teach. Okay. I'm leaving. Okay.